Hi. This is a presentation video for the EBICS API. EBICS API is a simple and fast way to integrate with bank accounts using the EBICS protocol. In the next video, we will go through instructions on how to use the application, authorization, adding connections, distributed signature, scheduler, and API. Welcome to the presentation. EBICS API is an application that allows you to manage banking data easily through a simple and intuitive interface. It provides integration of your application with the bank through a simplified REST API. The EBICS protocol is used for communication with banks. The EBICS API application can be deployed on your own web server or run locally. EBICS API supports multi-user mode. There are two ways to sign in, through GitHub or through OpenID. The easiest option is signing in with GitHub. OpenID requires additional configuration of the corresponding service. I click on GitHub Sign In. You can use your own GitHub application, but currently a shared GitHub application is used. Then I click Authorize. Great! I am signed in and can now configure my connections. Now I will demonstrate signing in with OpenID. To do this, I log out of the current account and click OpenID Sign In. Sign in is complete, and now I have another account. Each account has its own connections. There is also an option to share personal connections with other users, but I will show this later. That's all for now. The next step is to add a new connection. In this video, I will demonstrate how to create a new connection. A connection is a link between your local server and the bank's server. You can create multiple connections, and each bank account must have its own dedicated connection. To create a new connection, you can click the Create Connection button on the banner, or go to the Connections tab and click Add Connection. Next, enter the account parameters that were previously provided by the bank. For this demonstration, I am using a test account. In most cases, these parameters are sufficient. However, some banks require additional or specific settings. To configure them, open the Advanced Settings section. Here, you can set a custom name for the connection. By default, the option Generate and Store New Keyring is selected. The connection to the bank is established using EBICS version 3. If required, you can select a different version to support older bank servers. The is certified option must be enabled for version 3. For versions 2.4 and 2.5, this option is optional. For French banks, this option must always be enabled. The period option is used for the generated keyring certificates. The Certified by Root CA option is used when a bank-trusted root certificate is available. This allows the connection to be activated without manual confirmation from the bank. The next option, Authorization version, is set to the latest version, A6, by default. However, some banks only support the older A5 version. The Custom Signature option allows you to use your own signature. You can choose to use signing certificates from a USB token or upload certificates from files. When using a USB token, select the device and enter the PIN. This provides an additional level of security. Alternatively, you can upload your own certificates, which will be used instead of the certificates generated by the application. There are also additional options available, such as Upload Existing Keyring. This option allows you to upload an existing keyring for the connection. Another option is Do Not Store Keyring. When enabled, the keyring is not stored in the application and is instead passed directly with each request. I will now return to the default settings and click the Create button to create the connection. Alright. The connection has been created, and now it needs to be activated. To activate the connection, click the Activate button. Then send the initialization request to the bank server by clicking Send Initialization. Next, we need to send a PDF letter to the bank. If we click Confirm Activation at this stage, a message will appear indicating that the account has not been activated yet. So, I download the PDF letter by clicking Download PDF. Let's assume that the bank has already activated the connection. For test server, this bank activation is not needed. After that, we can click Confirm Activation. Everything is successful, and now we have an active connection that we can use to perform various actions. There is a Renew button, which generates a new keyring and marks the old one as outdated. The Suspend button is used to freeze the connection. After suspension, no actions can be performed until the bank reactivates the connection. There is also a Distributed Signatures button, which is used to manage uploaded data that requires an additional signature. This topic will be covered later. The Order Types button allows you to send requests to the bank server to download or upload data. I click Order Types to see which orders are available for this connection. The previously created connection is selected by default. Now we can choose an order type from the list. For example, BTD is used for downloads, BTU for uploads, and there are also other technical order types available. As an example, let's select the HAA order and execute it. After execution, we can review the data or download it. The application also allows you to share your connection with other users of the system. To do this, the user must have the administrator role. Once this requirement is met, the Share button becomes available. When you click it, a dialog appears where you can select the users to share the connection with. You can also enable the Is Shared with New Users option. This ensures that all newly created users will automatically have access to this connection. Save the settings, and then log in as the user with whom the access was shared. On the Connections tab, we can now see the shared connection. We can perform the same actions as the connection owner, except for editing the connection settings. For example, we can view the connection details. We can also execute various orders. Let's download some data as an example. Select some BTD order to download. Click Execute. Alright. The EBICS server has responded that there is no data available for this request. This is completely normal. Now let's upload data to the EBICS server. There is an ES flag field, which can be used when an additional signature is required for processing the uploaded data. Select the file to upload and click the Execute button. The upload was successful, and now we can view the connection logs. Here we can see which requests were sent to the EBICS server for this connection. Next time I will demonstrate distributed signature functionality. In this video, I introduced the distributed signature functionality. The EBICS distributed signature feature allows you to sign an uploaded document for further processing. This functionality requires multiple bank accounts. One account uploads the document. Another account applies the signature. First, I demonstrate how to upload a document with a flag indicating that an additional signature is required. For the first connection, we upload the file. You need to enable the ES flag and complete the upload. Next, using the second connection, we review the signature requests. Here, we see two documents waiting to be signed. The Sign button is used to sign the document. The Cancel button is used to reject the document. You can also view the document details and the document content. After the document is signed, the bank processes it. In this video, I will show you how to automate uploading and downloading data on an EBICS server. We can do this using the scheduler by setting up jobs for specific tasks. First, I will open the Scheduler Jobs page and add a new scheduler job. I select the connection I need. For example, to download data from the EBICS server, I choose the BTD order type. The data range sets the date interval relative to today for the download. You can set it to 1 day or any other interval. Next, I select the regularity, for example, daily at 4 a.m. UTC. For this demonstration, I will use the HAA order type, which returns data. By entering a webhook URL, each job run will send metadata about the results to the endpoint. After saving, I can try running the job. I can also check the logs to see the downloaded files. Now, I need to switch the job to run for regular execution. Next, I will create a scheduler job to upload data to the EBICS server. This time, I select the BTU order type. There is an option to set the ES flag during upload. In the path field, you enter the file mask. The dynamic part of the file name should be replaced with an expression. The next option allows deleting the local file after uploading. After saving, I can try running the job. Again, the job should be switched to run for regular execution. Finally, I can also check the logs to see the uploaded files. In this video, I will demonstrate how to use the application's API with your own systems. The current application fully uses this API and can serve as an example for integration. To authorize with the API, you need to pass an API key in the headers. You can get your API key by visiting the settings page. The API key is sent through the authorization header. You can also configure API keys for separate connections. To do this, go to the API key for connection page and add a new entry. Select the connection, set the permissions, and click Generate. Now, I will demonstrate the available API methods. At the top, there are links to ready-made libraries for fast integration with the application. Available methods include methods for connections, methods for queuings, methods for order types, Methods for access logs. Methods for scheduler files. Methods for distributed signatures.